All right, so MCR, section 2.3 notes, we're talking about formulas, going over how to solve for a formula. If the variable for which you're solving appears in a fraction, use the multiplication principle to clear fractions. Isolate the term or terms with the variable for which you are solving on one side of the equation. And we have our example, c equals 2 pi r. At this point, this equation is already solved for c, but we now want to solve it for r. Okay, so here's our example, c equals 2 pi r. We want to solve for r, so figure out what variable we're solving for. Well, it's this one. Decide what's going on so that it's not alone. So we can see that it's being multiplied by 2 and pi, which means we would do the opposite of that to isolate him. So he's going to be divided through on both sides by 2 pi. So now we know that r equals c over 2 pi. And that really is what this lesson is trying to help you understand. Never got it? Or are you getting ready to? All right, so here is another example. This one is very common to us. D equals R times T. What does this stand for? This is a motion problem. Distance
times rate. No,
Distance is equal.
Time. No.
Rate times time. That's right. Distance equals rate times time. It's okay. I understand. It happens to me all the time. So we usually see it, and we call this dirt. Some people call it a dirt problem. We usually see it in this form.
I see why. Oh, dirt.
Mm-hmm.
That's a good one.
That's a good one. All right. So if, though, I wanted to solve for time instead of distance, like if I had the distance and the rate and I wanted to know what time was, I could simply, before I ever got started, divide both sides by r. And so I would know that the distance divided by the rate is going to give me the time that I'm looking for. So this is us taking familiar formulas, which this one really, this is the circumference is 2 pi r. That's another common formula, but you can take these common formulas and manipulate them so that they're more user-friendly or give you a more direct answer or whatever. Okay? You could also have taken this equation if you wanted to solve for rate, and you would have gotten d over t would equal the rate. Okay, so that's me manipulating our standard formulas. Mm-hmm. All right, does everybody have the circumference formula written down?
Oh.
Yep. And we're going to have another example. This is 3x minus 4y equals 10. And this one we're going to solve for y. And usually when in the book, I don't want to say usually, but often, if they give you this equation and they want you to solve for a certain variable, they'll just put a semicolon and put y. That looks like it's a J. Semicolon. And now it looks like an I. Whatever. They'll put a semicolon and give you the variable after it that they want you to solve for. Okay, so in this case, we're solving for y. Well, what do I need to do? I have to isolate the term that has the y in it, which is this one. So this term needs to go to the other side. So we're going to subtract 3x from both sides. And you'll end up with negative 4y equals negative 3x plus 10. But again, y is still not completely solved for. We're going to divide through now by negative 4. Just make sure that you divide each term in the equation by negative 4. So y equals, this is actually going to be a positive 3/4 because these are both negative. So 3/4 x minus 10 over 4 is reduced to 5 over 2. Okay, I just went ahead and reduced the fraction. And this is something that we're used to seeing as well. This is the equation of a line, slope-intercept form, y equals mx plus b. And that's why I wrote it exactly like I did.